So this is the last page of the lesson. I'm actually not going to do all the stat calculator work on it. We're just going to kind of go over the problem. If you need to go over that more, you can look back at the previous pages or even the last lesson where I first introduced it. So here we have the cooling temperatures of a freshly brewed cup of coffee after it is poured. The brewing pot temperature is approximately 180 degrees Fahrenheit. So this is how many minutes after coffee is poured and what the temperature is. Now, if I look at this data and just some knowledge of how coffee works, I'm guessing this is a very well covered cup of coffee, where there's just a little hole to drink out of, because coffee just put out in a regular cup with the whole top open would cool a lot faster. So I would put this in L1 and L2. I would make a scatter plot by pressing Y equals, plot 1 on, and zoom 9, and my scatter plot would look kind of like this. So it would have an axis, and it would come across, and this is not perfect by any means, but we're going to look at what type of pattern there is in the data. So this one is not super clear, but it is actually an exponential curve. It has a little bit of curve if you did the scatter plot. So in this question, based on the scatter plot, what type of regression would best model the data? That is exponential. Now we're going to find the appropriate regression equation with coefficients rounded to the nearest hundredth. So in my calculator, I would go to stat and then calc and choose 0 for exponential regression, and I would get an equation in the form y equals a times e to the x. And those numbers that I plug in would be 172.18 times 0.99 to the x. Interpreting those parameters, those numbers I plugged in of the regression equation in the context of this situation, we know when an equation is in this form, this is the start value or the y-intercept, and this value is the growth, or in this case, decay factor. So what that means in the context of the problem, this 172.18 would be the starting temperature of the coffee, or when the coffee is poured, the temperature is 172.18. Now, that's not completely accurate to what we see in the table, but that's the curve of best fit. So based on all the points, the curve would fall slightly below that point at 179.5. So the growth or decay factor, the 0.99, if I do 1 minus 0.99, I get 0.01. Time is measured in minutes, so that means the temperature is decreasing 1% per minute. Now the next one says, using the regression to the nearest minute, when is the coffee at a temperature of 106 degrees? Now pretty soon we're actually going to have an algebraic way to solve this, but for now I'm just going to use a table. So I am going to graph, just get this set up, this function. So y equals, and we have 172.18 times 0.99 to the x. Now, based on my table, to get down to 106 degrees, I can see it's somewhere in this area. To speed up so I don't have to scroll so much, I'm actually going to go to my table set. This is what you should see. I'm going to start my table around 35. Okay, so I'm going to start looking, and this is just a way so I don't have to scroll. So it's like skipping to a certain start value. Sorry about that. Start the table here, and we're going to go by ones. We're going to the nearest minute, so we're just looking for the closest minute. Start going by ones. I had that backwards at first. So I go in my table. I'm looking for 106 in the y value because that's a temperature, and it looks like about 48 is the closest, so 48 minutes. So to show my work on that, because I'm not using algebra, I'm just using a table, I'm going to make an XY chart. and show something above, something below. So I have about 107.36, 106.29, and 105.22. So this is the one I want, 48 minutes. The next one says, using the regression equation, what is the predicted temperature of the coffee after 1 hour? So now I'm given a time value. Now I can't plug in 1 because my time is measured in minutes. So here I have that the x value is 60 minutes, right? 1 hour, 60 minutes. So since I already have my table up, I could use a table. I could also plug in 60. Either way is fine. Since I'm already here, I'm going to use the table. So I see here when I plug in 60 that I get 94, about 94 degrees to the nearest degree. I'm going to show it both ways so we can look in the table, but also if I was going to plug this in my calculator, the 60th, I would get that 94 degrees to the nearest degree. The last question, a long time ago, someone sued McDonald's because her coffee was too hot and she burned herself. It says in 1992, a woman sued McDonald's for serving coffee at a temperature of 180 that caused her to be severely burned when the coffee spilled. As a result of this famous case, many restaurants now serve coffee at a temperature around 155 degrees. Using this regression, how many minutes should restaurants wait before serving coffee to ensure that the coffee is not hotter than 155? Round to the nearest minute. So if I look in my table, I see 155. It looks like around, between 5 and 11 minutes in my table. So I'm going to go to table set again, and I'm going to back it up. So maybe I start at 5 now by ones. I'm looking for that 155. It looks like it's somewhere between 10 and 11 minutes. I want to make sure it's below 155, not hotter than 155. So I'm going to say 11 minutes. So let's just copy that part of the table to show work, and then we'll round to the nearest minute. And you'll see with some of these questions, we have to make decisions based on the type of problem, if we're going to have to wait extra, if we're going to round to the closest number. And in this case, it would be better to wait for the 11. So 10, 11, and 12 I'm going to show. Copy on those values. So I'm going to write 11 minutes. And just to be clear as to why I picked the 11 and not the 10, to be below 155 degrees.